Hey everyone, how y'all doing this morning? Alright, so go ahead and get out your notes. They look like what I have on the page here. It should say angle of elevation and angle of depression. Okay, so we're taking what we learned last week, trigonometry. Finding angles and sides using sine, cosine, tangent. And what we're going to be doing here is we're going to start applying it to word problems. Okay, alright, so let's go ahead and look at this front left side where it says angle of elevation. Okay, alright, an angle of elevation, okay, is the angle between the horizontal and the line of sight to an object when we look up. Okay, so a lot of new words here. All right, so an angle of elevation, all right, that's going to be this guy. Remember this symbol, theta? Okay, this is our angle of elevation. Okay, I'm just going to abbreviate elevation, E-L-E-V. All right. Okay, so we have the angle of elevation. That's the part that we're given. It's always going to be in that bottom right-hand corner for us, okay? All right, then the next vocabulary word is our horizontal that they talk about. Well, that's talking about the line that's horizontal, this guy right here that I'm highlighting. All right, so we're going to label that horizontal. And the last thing says line of sight. So see our little dude over there? He's looking up at that hot air balloon. All right, wherever he's looking or whatever our object is looking at, that is our line of sight. Okay, in this case, our guy is looking up towards the balloon, so our line of sight is up. So that follows our definition of angle of elevation is when we look up at an object. Okay, the line of sight is the imaginary path that our eyes follow when looking at an object. Okay, so let's look at an example over here. Okay, all right, Lisa is standing at the bottom of a hill. The angle of elevation from her to the top of the hill is 64 degrees. If the hill is 79 feet tall, how long is the path up the hill? So what we're going to do, whenever we see a vocabulary word, we're going to highlight it or underline it or circle it, whatever you want to do. In this case, it's angle of elevation. Okay, so this is what we're going to do every time we see angle of elevation. So you see kind of how we, I want to highlight it in red. We make a triangle out of this. I'm going to highlight it here at the top. Okay, see how we make a right triangle that looks kind of like that? We're going to make the same looking right triangle every time we see the word angle of elevation. Okay, so here's my triangle. And then in the corner down there is my right angle. Okay, so now we got to take our vocabulary words or our description of our path or whatever we're doing, and we're going to kind of draw around this triangle, okay? So they said Lisa is standing at the bottom of the hill. So at the bottom of the hill, I'm going to draw Lisa. Here's her hair, see? Okay. All right, she's standing at the bottom of the hill and looking at the top, okay? So here's the top of the hill. All right, and they said the angle was, well, if we looked at the top where our angle of elevation was, it's in the bottom right hand corner, and they said it's 64 degrees, so I'm going to label this 64 degrees. Okay, all right, and then they said if the hill is 79 feet tall, so what part of the triangle tells us how tall it is? Okay, do we measure how tall something is laying down on its side, diagonally, or straight up and down? Hopefully you said straight up and down, which is right here. Okay, and we're going to label that 79. Okay, and they want to know how long is the path she's going to go up the hill. So the path that we're going to take is this part right here. We're going to label that X. Okay? All right, so now let's go ahead, let's circle our angle. we got to figure out how to label our sides. Okay, so as usual, across our 90-degree is our hypotenuse, and across our angle is our opposite. So, all right, my old age, and I'm never could spell it, so SOHCAHTOA. How do we spell it? SOHCAHTOA. Alright, so we got SOHCAHTOA there. Alright, which one are we going to use to find x here? Which one uses opposite and hypotenuse? Alright, we're going to use sine. Alright, so we write SIN, what always goes in our parentheses, our angle. So 64 degrees goes inside, equals, what's our opposite? 79 over our hypotenuse, which is x. Okay, so x is where? Up, high, down, low, or inside? X is down low, so we divide, so we do 79 divided by sine of 64 equals x. Okay, go ahead, type that in your calculator. Give you guys a second. Alright, you should get an answer, and it should be x equals 87.9 feet. Okay, that's how far she had to travel up the hill. Okay, example 2. Okay, a deer is standing 42 feet from the base of a 75-foot tall tree. What is the angle of elevation from her to the squirrel sitting at the top of the tree? Okay, what's our vocabulary word? Angle of elevation. So we're going to draw that same triangle. There we go. Okay, so a deer is standing at the base of a tree. Okay, so the tree, how does a tree stand? Does it stand vertically, horizontal, or diagonal? Hopefully you said vertically. So here's my tree with my little squirrel up top with his little bushy tail. Okay, and then I got a deer. I know my deer is really good looking, right? Okay, so there's my deer. Give him a little tail. There he is. Alright, so let's go ahead and start labeling this. A deer is standing 42 feet from the base. Okay, so the base is at the bottom, so the 42 is going to be down here. Okay, from a 75-foot tall tree. Well, we measure the tree is 75, so I'm going to measure 75 right there. They want to know what the angle of elevation was. Okay, so the angle of elevation, we always label that in the bottom right-hand corner, but we don't know what it is, so we're going to use x to represent it. Okay, so let's circle our angle, label our sides. So across our right angle is our hypotenuse. Well, we don't have a value there, so we're not going to use that, but it'll help us label the others. Across our angle is our opposite, and the side that connects our angle to our right angle is our adjacent. So what are we going to use? Add a sine, cosine, or tangent. Hopefully you said tangent. So we write TAN, and our angle is x in this case, equals tangent. TOA use opposite over hypotenuse, so whoops. So we get 75. I said opposite over hypotenuse. It's opposite over adjacent. 75 over 42. There we go. Alright, is x up high, down low, or inside? X is inside, so we circle, circle, switch, switch. And then we rewrite the inverse, so tangent inverse. And we write 75 over 42 equals x. Okay, and then go ahead and type that in your calculator and tell me what you get. I'll give you guys a second. And we get x equals 60.8 degrees because we're finding an angle. Okay. Let's go over to the next side. All right, where it says angle of depression. Okay. No, not the depression like you're sad. Okay, but it can kind of help us remember what to do here. Okay. So, angle of depression. An angle is of depression is the angle between the horizontal and the line of sight. Hey, that sounds kind of familiar, right? Looks really the same over here, except that it's when we look down at an object, okay? All right. So just like in these blanks, this is also line of sight. All right, it's where we're looking at. All right, so this is our angle of depression. Okay, he's inside the angle. Now notice the difference between the angle of depression from our line of elevation and our depression. This time our angle of elevation is up at the top left, okay? And our horizontal is still going, is our line that goes side to side. And our line of sight is our diagonal, okay? But notice our line of sight is on the bottom of the horizontal. Over here, our line of sight was at the top. Okay, so that's the difference between the elevation and depression. Okay, all right. So let's look at some examples down here. So we have the angle of depression from a fisherman on top of a cliff to a boat 320 feet from the base of the cliff is 27 degrees. How tall is the cliff? Okay, so we're going to draw another triangle, all right, but it's going to look kind of like the one I'm highlighting right now. It's going to make a right triangle, but kind of upside down, okay? So go ahead, let's draw our triangle. And there's our right angle. Okay, so our little fisherman, he's up here fishing. That's what I did this weekend. He's got a little fish, okay? He's trying to cast it. All right, off the top of the cliff to a boat down at the bottom. All right, so here's a boat. Okay, there's our little boat. Make my sails look better. How about that? Is that better for you? Okay. All right, so the boat is 320 feet from the base, okay? That's from side to side whenever they talk about that. So the part of the triangle that we're going to label 320 is our horizontal, okay? And our angle of that they're looking at is 27, so that goes on the inside, so it's 27 degrees. They want to know how tall the cliff is. So would that be our diagonal or would be that the vertical? Hopefully you said vertical, and that's going to be our x. Okay, so let's go ahead, circle our angle, label our side. So the side across our angle is our opposite, and the side that connects our angle to the 90 degrees is our adjacent. Okay, so using SOHCAHTOA, I'm going to rewrite it over here for you guys. SOHCAHTOA. Okay, what do we use? Adjacent and opposite. It's going to be TOA, so we're going to write tangent. So TAN, parentheses. Okay, what's our angle? 27 equals what over what? Okay, well, TOA says opposite is on top, so x is on top, and then 320 is going to be on the bottom. All right, x is up high, so we multiply. All right, so we get 320 times the tangent of 27 equals x. Go ahead, type that in your calculator and tell me what you end up getting. You should get x equals 163.1. What did we measure this in? Is this going to be an angle or or feet? Hopefully you said feet because we're measuring distance. Okay, so this is 163.1 feet. Alright, so let's look at one more example and then I will help you guys set up the other problems and we'll go from there. Alright, so example 2 says a tower of an ancient castle is 331 feet tall and casts a shadow that is 388 feet long. What is the angle of depression that the sun makes with the ground to create the shadow? Okay, our vocabulary word was angle of depression. So we're going to draw our angle of depression triangle. Alright, so let's go ahead and find out our information. So an ancient castle is 231 feet tall. Alright, what part of the triangle represents how tall it is? It's our vertical. Okay, so let's go ahead and label that 231. Okay, and a shadow, okay, is 388 feet long. Okay, our shadow. So when we're standing outside and the sun's shining down and we see our shadow, is our shadow at a diagonal coming off the ground or is it flat on the ground? The shadow is flat on the ground, so our horizontal is our length of the shadow. Okay, so we're going to label that 388 feet. They want to know what our angle is, so our angle is on the top left. So we're going to label that x. Alright, let's go ahead and circle our angle and label our sides. So across my angle is my opposite. The side that connects my angle to the 90 is my adjacent. So I use tangent. X is my angle, so it goes inside my parentheses, equals 231 over 388. Okay, where is x? Is x inside, up high, or down low? X is inside, so we use inverse. So we circle, circle, switch, switch, inverse. Okay, so 231 over 388 equals x. Go ahead, type this guy into the calculator. Give you guys a second for that. And tell me what you get. Well, you can't kind of tell me, but you can at least write it down. Alright, you should get x equals 30.7 degrees. Okay, because we're measuring an angle there. Alright, hopefully this isn't too bad. The hardest part about this is being able to label our triangle. Alright, so whenever we see depression, we're going to draw the triangle that looks like what we have here, our angle of depression triangle. And then if we see elevation, we're going to draw a triangle that looks like this. Alright, so let's go ahead and look at our examples. Open this up or flip it over to the other side. And we're going to look at some examples here and try and set you up. And then you guys are going to work them out yourself. I think you guys can be able to solve these on your own. Okay, so let's go ahead and get our highlighters or pencils or to be able to identify our vocabulary words to draw our triangles. Okay, number 1, the angle of elevation from point A to the top of the cliff is 34 degrees. If point A is 1,000 feet from the base of the cliff, how high is the cliff? Alright, so what's our vocabulary word? It's angle of depression. Angle of elevation. Sorry. Alright, so there we go. So we're going to draw our triangle that looks like this. Alright, so we're going to draw our triangle. And they said point A is where? Where is point A on our triangle? Point A is 1,000 feet from the base of the cliff, so at the bottom. So down here, I'm gonna put point A. All right, and from the base of the cliff, okay, so that's how far away he is, side to side. All right, that's 1,000. Okay, well, our angle always goes where? Where did we always draw our angle for angle of elevation? In the bottom right-hand corner. Okay, so we're going to put our angle there, so that's 34 degrees. And they want to know what? How high is the cliff? All right, so our height is represented by the vertical line, so we're going to put X there. All right, I think you guys can work it out from here. If you need a little bit more help, I'll help you label your sides. So there's our angle. Across our angle is opposite. And the side that connects our angle to our 90 degrees is our adjacent. All right, I'm going to let you guys figure out the rest on this, and you'll do it on your own. Okay, let's look at example 2. A ladder is leaning against the top of a building. If a ladder is 12.5 meters long and 3 meters from the base of the building, what is the angle of elevation from the ladder to the top of the building? What's our vocabulary word? Angle of elevation. So we're going to highlight that, and we're going to draw our triangle that goes along with it. Okay? Ooh, I made a pretty triangle. Alright, so there's my 90 degrees. Alright, so our ladder. When we lean the ladder up against our building, okay, our ladder is diagonal. So that is our 12.5 meters there. Okay, what else did they say? They said 3 meters from the base, so from of the building. So that's how far away it is. So our 3 is down here. Now what do they want us to find out? It says, what is the angle of elevation? Okay, so we need to find out what the angle is, and that's going to be down in the bottom right. Okay, so circle our angle. All right, across my 90 degrees is my hypotenuse. Good. And then the line that connects our angle to our 90 is our adjacent, so I think you guys can figure it out from here. Okay, so just make sure that you use all the stuff I have up on the board to help you work it out. All right, number 3. Lifeguard is 6 feet above ground. She sees a swimmer at an angle of depression of 8 degrees. What is the horizontal distance to the swimmer? Okay, so there's a lot of vocabulary in here, but it says angle of depression. So we're going to draw our angle of depression triangle. Okay, if you forget, this is what it looks like right up here. Okay, we're going to draw a triangle that looks exactly like that. There we go. All right, draw your right angle. There we go. Okay, so how far off the ground is the lifeguard? 6 feet above ground. Okay, so when we say above ground, we're talking about our vertical distance. Okay, so that is 6 on the side here. Okay, she says that the angle of depression is 8 degrees. So we always draw our angle in the top left. So that's where we're going to write that 8 degrees. Okay, they want to know what the horizontal distance. So that's kind of an important word there, horizontal distance. All right, if we look at the top up here, our horizontal line, that looks familiar. So we should probably label that the horizontal distance as well. And we don't know what it is, so we're going to use X to represent it. All right, circle your angle, label your side. So across our angle is our opposite. And the side that connects our angle to our 90 is adjacent. Okay, I think you guys can go from there. Let's look at the next one. All right, a child holds a string of a kite which is flying in the air. If the angle of depression from the kite to the child is 42 degrees and the kite string is 40 feet long, how high is the kite in the sky? So, what's our vocabulary word? Angle of depression. Okay, so we're going to draw that triangle. There we go. And we're going to label it. Okay, so this said the angle of depression is 42, so that's where our angle goes. And the string is 40 feet long. Okay, so if we have our little person down here holding the string, right, to the kite. Oops. Alright, so that string is 40 feet long. They want to know how high is the kite from in the sky. So our height is represented by our vertical line. We don't know what it is, so we're going to label it X. Okay? Alright, circle your angle, label your side. So across my angle is opposite, and across our 90 degree is always our hypotenuse. And I think you guys can go from there. Alright, if you have any questions, feel free to rewatch the video or save them for tomorrow. What you guys have coming up next is some more practice for this. Please use your vocabulary, please use your notes. If you have any questions, I'm available during block lunch tomorrow, or you guys can just see me in the halls later this afternoon, okay? Alright, I hope you guys have a great rest of the day. I'll see you later. Bye.